Cheers. If you're in this talk, you may be used to your phone looking a little bit like this, perhaps more often than you'd like. In your last shift, you had your sleep interrupted on a few different nights, and by the time it was over, you couldn't wait to hand off the pager. You can't remember the last time that you had a quiet week, but you're sure that it wasn't always like this. Over the next 15 minutes, I'd like to convince you that this is fixable, and I'd like to talk you through a situation my team found myself in where we had to do just that. But first of all, hi. My name is Chris. You can find me on the internet at sinjo.dev. In my spare time, I like to post ridiculous selfies on the internet. And during the day, I work as an infrastructure engineer, which is kind of a mixture of software and systems work. I do that at a database as a service company called PlanetScale. And I'm going to jump into today's talk by showing you a graph. I want to tell you about the time that our pager got really out of control last year. I'm going to focus on how we dug ourselves out of it, turning this into this. But to set the scene, I want to start off with how we got there. What did it look like beforehand? So we've got this kind of before and after graph. Things got really bad going from August into September and in October, and then things got better somehow. But 2023 hadn't exactly been all sunshine up to that point. Our baseline that we were working from was a few hundred pages per month, which is kind of high. Like if you do the maths and work out how many per day, that's quite a lot. And some of this was down to flappy alerts and things that you get multiple alerts for one issue. So the numbers might be a little bit overrepresented here, but they paint a picture. And when that load ramped up in September, our team really started to feel it. We'd gone from a few interrupted nights of sleep in each week shift that we did to every night being interrupted 2 or 3 times, which is just, well, it's quite brutal. The first challenge we faced, though, was convincing ourselves that we actually had a problem. And you might be thinking about those graphs I just showed you and thinking, well, it's obvious, it's in the graphs. But back then, when that was happening, we didn't produce pager graphs for what was going on. We were doing all of this kind of week-to-week analysis purely based on vibes. We knew it didn't feel great, but it took a little bit of time for us to agree that we actually had a problem that wasn't going to go away and we needed to do something. It was super common to hear phrases like this in handovers. Oh, not much to report, nothing interesting from my shift. And part of the problem was that those few hundred pages per month that we were receiving had got us accustomed to a really noisy pager already. And truthfully, that second statement was kind of right. A bunch of the pages weren't interesting, they weren't novel, there were just a lot of them. But if nothing interesting happened, then why did a computer wake you up every night of the week? Often multiple times in the same night. And the way that we finally agreed that we actually had something to deal with as a team was to produce this data. And if you're having discussions that sound similar to that, I would recommend step 1 is producing graphs that look like that to talk about. As soon as you put it in a bar chart, there's no hiding. And especially if you separate out the fact that some of these are at night, or rather a lot of them are at night, you just can't hide away from the fact that this is happening. You get rid of the vibes-based conversation, and you turn it to a graph. So what do you do once people agree that you've got something that needs fixing? Well, here's where your 500 easy steps come into play. And really, it's 3 steps over and over again. Every week, you take your alerting data, and you group your alerts by name. You sort those alerts by frequency, and then you do a little bit of manual work to categorize those alerts. So you may end up with a table that looks something like this, but probably a little bit longer. At the top, we've got HTTP error rate high. At the bottom, we've got autoscaler maxed out. These are just some arbitrary examples. They'll look different in your systems. The good thing about this is it keeps you away from any tendency to fix technically interesting problems that won't bring your pager load down by very much. You want to focus on the things that are at the top, that are waking you up the most, and then maybe later come back for the stuff that kind of looks fun to work on but won't actually make a meaningful difference to this. And I mentioned a kind of manual step of categorizing. The way that we did this was we started from the top, and for each alert we said, is this alert mostly right, or is this alert mostly wrong? And this is actually something that I wish pager tooling would bake in. I've not seen it in any of the major ones out there, but please tell me if I'm wrong about that. I wish it would say, here's all the pages you got today. Could you just quickly click, like, these ones were correct pages and these ones were noise? Because then you'd have data on it at the end of the week. But for now, we do that manually. And let's start with the ones that are mostly right. These are actionable alerts. When they ring your phone, you go and fix something in production. But you might have too many of them. Generally speaking, it is easier socially to fix this category of problems. Everyone agrees that there is some software that needs fixing. This leans more into your technical skills, your ability to either fix alerts or fix the software that's causing them. And what you need to do that is have buy-in within your team, from your manager, perhaps from a director, to spend time on fixing bugs, improving automation, rather than on product features. And when I say automation here, I mean anything where you're bothering a human to go and do a task that a computer could do. That could be scaling things up or down, out or in, or even scaling disk sizes in the case that you're running quite a stateful something or other, like a database, for example. Cool. Now, alerts that are mostly wrong are actually, in many ways, the more interesting thing. You'll see these a lot of the time, and they can be caused by transient errors that resolve themselves with little to no user impact. And I say they're more interesting because these are very easy from a technical point of view a lot of the time, but they are difficult socially. In a lot of cases, it's really hard to convince people to let go of an alert that they wrote 2 years ago, because they know the incident that they wrote it for. And changing people's minds is a lot harder than changing a couple of lines of PromQL. It's so easy to introduce new alerts, but it's actually quite hard to retire them. It's something that you're going to have conversations about rather than going away and like editing code. But you end up in this situation where you've got so much background noise from these alerts that used to be useful. You accumulate them all, and now you're being paged by just all kinds of stuff. And when I'm having this specific conversation with different people, there's kind of 3 main things I tend to focus on. Because while reducing pager load is a worthwhile goal in itself, at least I believe so, it's often not enough when said alone to win people around to this argument. The 3 I focus on are pager fatigue, the fact that if we get so many unactionable pages, we are likely to miss the actionable ones, or ignore a real issue because it's indistinguishable from the noise. Tiredness. Tired people generally don't do their best work. If you're waking people up throughout the night, then that's going to spill over into what they do during the day. And lastly, I think this one's more subtle, but also really important, is the sense of learned helplessness. A team can lose its belief that it can make things better if they're just in this endless cycle of acking pages that they don't have to do anything about. And I think that's a really horrible situation for a team to land in. And so when you're faced with a barrage of these unactionable alerts, you have 2 choices. You can make the alert more precise, or you can delete the alert. And I believe that. It's one of those 2 things. An alert that is actionable 1 time in 10 or 1 time in 100 is worse than no alert. Now, sometimes things aren't quite that clear-cut. Sometimes alerts are actionable, but they alert in a really annoying way. They often just need a small change to become good alerts. The most common of these is excessive urgency. We often default to writing alerts that page us rather than tell us about the problem in a more low-key kind of way. Well, the reality is things can wait till tomorrow sometimes. So you could fire that message off into Slack or create a ticket. Another one is flappy alerts. These are the ones that fire and resolve, and then you fix the problem and it finally goes quiet. The most common reason I've seen for these happening is to do with how you're calculating rates over your metrics. So if you calculate the rate of errors over a very short period of time, a spike of alerts will set a spike of errors will set the alerts off. Then the errors go down a bit, the alert resolves, up, down, and it flaps. If you're using something like a 1-minute window, extend that out to like 3 or 5, and you'll probably solve the problem. The last of these weird cases is pager storms, where one single sort of logical issue causes many pages to go off. And here you want to look into slightly more advanced features of your paging software. One of them is to do with how you group alerts. So you want some way of expressing that if this same thing happens in many places, that turns into one page. And the second one is alert inhibition, where if you've got one alert that tells you that, say, an entire cluster is down, you don't want to receive individual alerts about each piece of software in that cluster because you already know the whole thing is off. Cool. What happens when things get thorny? What happens when we run other people's software and that software breaks and pages us? This is really common, right? Like, we all run a bunch of open source software, most likely in our stacks, and sometimes something from another team can page us as well, even if it's within the same company. That case where things are inside our company is kind of a little bit easier because it's easy to go and have a conversation with those people. Team boundaries aren't perfect, software boundaries aren't perfect. Sometimes you will cause another team a page, sometimes it'll happen to you. And you want to make sure you've got each other's backs during these things. There comes a point, though, where if you've got an alert that mostly fires because of changes in someone else's software, then that alert is probably owned by the wrong team at the moment. And I want to emphasize that at the moment part, because when you're having this conversation, you can get into this sort of difficult kind of uneasiness around, oh, you're just trying to offload your pages onto me. And one of the things I find diffuses that is saying, look, if it turns out that this page is being caused more often by my team again, we'll just send it back. That's a one-line edit in some YAML. Like, work with your other teams that way, and it just diffuses it a little bit. But what about when the people writing the software are not in your company? A lot of our software, as I mentioned, is open source these days. Like, a lot of people in the room presumably run on top of Kubernetes or something similar to that. What do you do when there are bugs in that? Well, I'm a strong believer in working with maintainers on this stuff. A lot of open source projects are starved of high-quality bug reports, and they're drowning in 3-line reports that say it doesn't work, and basically no more details. So whenever you run into something really weird, this was a case where we ran into a roughly 1 in 100,000 occurrences bug provisioning disks in AWS's Kubernetes flavor. We sat and figured out the rough sequence of events that were going on. We talked to the maintainers, and a few months later, a fix was out. It's all good. This is worth doing. This will make your life better as well as the community software better. But in those few months, you kind of want to protect yourself. And to do so, we've implemented rather some automated remediation tooling internally. And I want to give you a quick look at what we've done there, but I also want to emphasize that you really have to think about the safety of building something like this, and that this is a Band-Aid and not a solution to all problems. The core of this is something that none of us are comfortable about here, which is that often restarting a piece of software fixes the software. For a little bit, anyway. This can apply to problems of a very particular shape. First off, it needs to be something that happens a lot. It needs to happen, I'd say, at least every on-call shift, every week or so, but probably more often than that. Do not apply this to things that happen monthly. The second part is you need to be very reliably able to detect the problem. You only want this automation to take action in situations where you're absolutely sure that the right issue is being solved. And the last part is that the fix has to be purely mechanical. The on-caller pulls up some boring runbook and just pastes commands into a terminal. If you have a runbook that involves a bunch of diagnostic work, then this is not the right solution. And that last point is something I want to emphasize, actually. I'm not wholesale against runbooks. I think they can be really useful in providing context to someone who is coming into an issue fresh. But the ones that are purely mechanical, if you're waking up a skilled practitioner to type commands into a terminal, that is a huge waste of their time and talent. Mechanical work is what computers are good at. We can write software to do this for us, which is why we made AutoRepair, which is a little tool that runs in all of our Kubernetes clusters. It listens for a non-paging alert that is sort of primed to go off before the paging alert. And it runs, well, I'm not going to show you the real code because it's reams of Go error handling, but in a nutshell, it fetches the alerts from Prometheus that are currently firing. It filters those down to the name of the alerts that it knows how to fix and the particular labels. And then it runs a little piece of code that is specific to each alert type that goes off and applies some fix, restarts a Kubernetes pod, deletes something, kicks something over. And it's that simple, genuinely. Kinda-ish. The problem with building a tool like this is you can run into a problem of runaway automation. It's extremely easy to build something that goes off and makes the problem worse. And this is a real risk, and this is the main reason not to do what I'm talking about now. If you are going to go ahead and build something like that, you need to think about the limits that you build into it from the start. It's much more important what this tool doesn't do than what it does do. And in our case, we started with 3 limitations, and these have served us well until today, about a year later. If there are too many occurrences of a specific issue, we go with 3 or more usually. Do not try and fix it. Let it fall through to an on-caller, because there is probably something systemic going on, and that is where you want your skilled practitioner involved. Secondly, don't restart the same instance repeatedly. If 1 or 2 restarts haven't solved the problem for an instance of something, they're not going to solve it eventually. Let that fall through to the on-caller. And lastly, if something has already paged, do not delete the evidence trail and running process that you have just woken someone up to look at. That was less of a safety feature, more of an anti-annoyance feature. And for us, this saves us from high 1s to low 10s of pages on an average week. Goes up and down depending on particular versions of software that we're running. And yes, we still file bugs. So to boil this down into a few short takeaways, I want to emphasize that the thing you have to drive at if you want to bring down your pager load is that this is a long-term thing that you're going to be working on. It's not a project. It's not something that you work on and then put aside. And when you're having those discussions, you should emphasize the actual impact on customers. You'll often hear arguments saying that it's fine to page too often because then at least you don't miss anything. But once it's so noisy, you do end up missing stuff because you can't see the wood for the trees. The second lesson, and I believe this, is you should embrace hacky fixes that help you survive. Dogmatically insisting on an ideal solution in every situation doesn't make you a better engineer. Dumb ideas that work aren't dumb. Auto repair is definitely one of those, and I'd rather be in a team that accepts that kind of trade-off as it's needed. And lastly, it turns out good things happen if you turn this into a habit. We're about a year on now, and you saw earlier that we brought down that initial spike. But what happens if you keep applying that mindset again and again over the course of a year? Well, it turns out your on-call rota gets even nicer to work on, and we live in a much happier world now. And if your pager data looks like the left-hand side of this chart, I hope that by applying this technique can help you turn it into the right-hand side. Thank you.